Welcome to Technorazzi. I'm Dirk Ducharme. Last week we met with John Hammond of Indicate Technologies in Santa Clara, California. John demonstrated for us the capabilities of a multi-sensor vision system. This week, John shows us an entirely different type of vision system.
This machine here is the SmartScope Flash 500, manufactured by Optical Gauging Products out of Rochester, New York. It's equipped with a special microsensor that we will see the results of here, and we'll be also looking at the TrueMap software by TrueGauge that allows us to do some surface metrology analysis.
What we're going to look at today is kind of a unique application for this particular product. This is a well, you tell me what it is.
Well, it is interesting in that we're using the Flash 500, the SmartScope Flash 500, with the Rainbow probe to measure an electrostatic chuck for 300 millimeter wafers. These chucks hold wafers during their processing.
We can see the surface of this, and looks like there's very small raised pads.
The top surface of the raised pads define a surface where the chuck will be pulled against. The concave or void area next to the pads is generally called the field. The parallelism of the plane establishes how flat the wafer will be held, and the coplanarity between the top of the pads, which are called mesas, and the field below affect how well this wafer will be held in place.
And I'm assuming it being a semiconductor wafer that it's important that it be held pretty darn flat.
The flatter the better. This particular application is for a local customer here who is in the business of manufacturing electrostatic chucks as well as reworking electrostatic chucks that have been out in the field. The task at hand is actually during the rework process, and the idea is to know where the chuck is from a flatness and coplanarity when it comes in, do the rework process, and then re-verify it on the way going out before it's shipped.
Well, step us through it. Let's see what we got.
Okay. The instrument itself over here with the electrostatic chuck is set up on blocks. We use the vision system to locate the exterior of the chuck, and so that our scans with the Rainbow probe are done in a precise location. And then the Rainbow probe does a series of concentric circles, scanning, collecting a series of points, in this case hundreds of thousands of data points across that chuck surface. And once that's accomplished, we have taken the data into another software package, which is, in this case, TrueMap by TrueGauge. And this is a surface metrology package, so this gives us the ability to do further detailed analysis of the surface of this chuck. This particular image that we're looking at here on the screen is a 3D representation of the chuck surface with the pads as well as the field.
Let me interrupt you for just 1 second. Let me make sure I understand. You're saying the first thing that the SmartScope Flash did was used its vision capabilities to define the perimeter of the
Yes.
chuck. Is that what it did?
That's right.
Okay, and then using that allowed it to what, orient itself in order to preparation for the scan with the Rainbow probe?
Yes. Well, first of all, the software is cycling through this topographic map. Now, over here on the left, we see a top view of the data acquired from the Rainbow probe on the SmartScope Flash 500. And through the colorization, we can determine some height information. There's on this section over here, there's a color bar, and that has numbers associated with it. In this case, from positive 6 microns down to negative 28 microns. So that's the range of surface data across this chuck, including the top surface of the mesa as well as the bottom surface of the field.
So it looks like we have like a little hump.
Yes, we do. Okay. We have kind of a saddle effect or a potato chipping of the top of this chuck. As these go across here, these cross sections, we just have this cycling through each cross section, and we see a cutaway view of that here on the bottom of the screen. And let's pick one particular cross section here, for example. Okay. And we were to use our eye and our imagination to look across the top and connect the tops of these surfaces here. That would describe this cross-sectional view of the mesas or the pads. And if we were to look across this bottom section here, that's going to describe the surface of the field.
By the way, how out of flat is this? We see this hump here, but how big of a hump is that actually?
By positioning these cursors, we can make that determination. Position one at the location, let's say the high point, and maybe come over here to this side piece, and we can tell the Z delta here is about 6 microns.
So, not much.
Not much. About 2.5 tenths of a thousand.
Okay.
So even though that looks large on the screen and this looks huge here, it's really a very small amount.
And how long did it take to do this scan and come up with this data?
This scan is very dense. It took about 30 minutes to complete the entire scan.
Okay. Well, that's a very interesting application. Okay, thanks a lot.
You're welcome.